day, everyone. I am Lowell Almario, the first reporter of our group, and I was tasked to report about the inventions used for the transmission of information during 1946 up to 1948. So the first inventions. What was NIAC? The NIAC, or Electronic Numerical Integrator and Computer, was the result of a U.S. government-funded project during World War II to build an electronic computer that could be programmed. The project was based out of the University of Pennsylvania's Moore School of Engineering. The design team, including engineer J. Presper Eckert Jr. and physicist John Mauchly, under the leadership of Herman Goldstein. The team began work on the project in 1943. John von Neumann, a noted mathematician of the day, began consulting on the project in 1944. The machine was completed in February 1946 at a total cost of about $400,000. Its purpose was to help the United States win the World War II, but the war ended before the machine was finished. Instead, its first job was doing calculations to help with the building of hydrogen bomb. So, muna siya. This is the example of the one kani first invention to transmit information. Next, long-distance coaxial cable systems were introduced in the United States in 1946, employing analog FDM methods. The first coaxial system could support 1,080 two-way voice circuits by bundling together the three working pairs of cable, each pair transmitting 600 voices signals simultaneously. And the last analog coaxial system, deployed in 1978, each pairs of cable transmitted 13,200 voice signals on the cable. And the cable bundle contained 10 working pairs. This combination support 132,000 two-way voice circuits. Digital coaxial system were introduced into the U.S. long-distance network beginning in 1962. TDM, a digital cable system first deployed in 1975, can support up to 40,220 two-way voice circuits over 10 working pairs of coaxial cable. So, muna siya coaxial cables. Cute away drawings of multi-pair and coaxial cable. So, muna siya ang gitawag na coaxial cable. Next, the first bipolar transistor, point contact transistor fabricated on germanium semiconductor, was invented by W. Brittain and J. Barden at Bell Telephone Laboratories in December 1947. Soon after this, on 23 January 1948, Shockley 1948 invented the junction of sandwich transistor. Each layer and junction in the device performs a specific function and designs of each layer, thickness, composition, doping area, etc. The operational or the functional relation between all of these three layers determine the device performance parameters such as current gain and speed. In NP-based semiconductors, one can select materials for each layer with particular properties that provide a specific device performance. In NP-based material offer a large variety of materials with excellent electronic transport and band gap properties. The use of these materials with excellent properties translates into an outstanding device performance such as ultra-high-speed wideband operation, high RF gain, and compatibility with electro-optical devices such as photodetectors and lasers for high-speed optical communications. So, muna siya example sa device nga used during 1946 up to 1948. End of slide. That's all. That all includes my report, and once again, good day.
What is the Leo computer? A pioneering electronic computer built 1949 to 1951 to manage Lions T-shop orders, based on electronic digital computers developed and used during the Second World War, ran the world's first routine real-time office application. After the Second World War, Simmons sent two of his junior managers, Oliver Stanningford and Raymond Thompson, to investigate office methods in USA. They came back filled with enthusiasm for electronic computing. The American authorities had recently declassified the technology, and it was greeted in both sides of the Atlantic with excited headlines about electronic brains. Thompson and Stanningford had also discovered that Maurice Wilkes at Cambridge University was at the very moment building a computer, the Electronic Delay Storage Automatic Calculator, or EDSAC. EDSAC's electronics were thermionic valves or vacuum tubes, and its memory was stored in mercury delay lines, tubes of mercury that carried strains of pulses and more condensed from than in copper wires. Simmons quickly struck a deal with Wilkes to fund the project to the tune of €3,000 if Lions could build a copy once it worked.
1952 to 1954. Modes of information transmission include postal service, newspapers, posted notices, and telephones. Postal service was one of the medium for the exchange of information. It uses snail mail as a primary mode of communication. These mails were delivered to the designated address using the postal service. Newspapers. Town newspapers kept the villagers up to date about the happenings within and outside the country. Posted notices were used very often for the dissemination of not only advertisements but also notification of community events. Telephone. Although telephones were not that numerous in the year 1950s, only 60% in the US, telephones were very useful in transmitting information in the 1950s.
Planar transistor invention, 1957. Who is the inventor of planar transistor? Jean Horny. Jean Horny is a Swiss-American engineer, born on September 26, 1924, in Geneva, Switzerland. He developed the planar process, which is an important technology for reliably fabricating and manufacturing semiconductor devices, such as transistors and integrated circuits. On January 12, 1997, Horny died with myelofibrosis in Seattle, Washington at age 72. What is a planar transistor? This picture shows an example of a planar transistor. On December 1, 1957, physicist Jean Horny recorded a method of protecting exposed p-n junctions at the surface of silicon transistors by oxide masking techniques. His first impression of planar process was a radical new transistor design in which the oxide layer is left in place on the silicon wafer to protect the sensitive p-n junctions underneath. Due to concerns about possible contaminants, conventional wisdom required removing the oxide layer after completion of oxide masking, thus exposing the junctions. Horny viewed the oxide instead as a possible solution to his planar approach, named after a flat topography of finished device. Thank you all for listening, and that's all for my report.
Hi, my name is Edward. I'll be reporting a part of timeline for the information age in 1958. So, September 12, 1958, Jack Kilby of Texas Instruments built a circuit using germanium mesa, PNP transistor slices he had etched to form transistor, capacitor, and resistor elements. Using fine gold, or what he called the flying wires, he connected the separate elements into an oscillator circuit. 1 week later, he demonstrated an amplifier. Kilby's solid circuit concept was announced on March 1959 and introduced its first commercial device in March 1960, the Type 502 binary flip-flop priced at $450 each. So this is the picture of the first integrated circuit, or the ICs. It's comprised of only a transistor and other components on a slice of germanium. Kilby's invention has a size of 7/16 by 1/16 inches. It would revolutionize the electronics industry, helping make cell phones and computers widespread today. Thank you.
1961 to 1962. Development of MARC. MARC is the acronym for Machine Readable Cataloging. It defines a data format that emerged from a Library of Congress-led initiative that began nearly 40 years ago. It provides the mechanism by which computers exchange, use, and interpret bibliographic information, and its data elements make up the foundation of most library catalogs used today. MARC became US MARC in the 1980s and then MARC 21 in the late 1990s. That's all.
1963 to 1965. The ASCII, American Standard Code for Information Interchange, permits machines from different manufacturers to exchange data. The ASCII code consisted of 128 unique strings of ones and zeros. Each sequence represented a letter of the English alphabet, an Arabic numeral, an assortment of punctuation marks and symbols, or a function such as a carriage return. ASCII can only represent up to 256 symbols, and for this reason, many other languages are better supported by Unicode, which has the ability to represent over 100,000 symbols. Next is DEC tape is introduced. It was a modification of DEC's earlier link tape, and as a reliable and inexpensive storage medium, was used in several generations of DEC mini-computers. The 3/4-inch tape was widely thought to be an improvement over paper tape, and part of its reliability stemmed from the fact that it was laminated and the magnetic part of the tape was sandwiched between two layers of mylar. DEC tape was often used as a form of personal data storage, as the small reels could be easily hand-carried. Next, the Control Data Corporation, or CDC 6600, performs up to 3 million extractions per second, 3 times faster than that of its closest competitor, the IBM 7030 supercomputer. The 6600 retained the distinction of being the fastest computer in the world until surpassed by its successor, the CDC 7600 in 1968. Part of the speed came from the computer's design, which used 10 small computers known as peripheral processing units to offload the workload from the central processor. Next is the 3C DDP-116. Designed by engineer Gardner Hendry for Computer Control Corporation. The DDP-116 is announced at the 1965 Spring Joint Computer Conference. It was the world's first commercial 16-bit mini-computer, and 172 systems were sold. The basic computer cost $28,500. That would be all. Thank you.
So good day. My name is Lord Michael Alcala. I'm the reporter of Science, Technology, and Society, 1966 to 1968. So, technological breakthrough in 1966 as ECPI University was opening it to teach students how to not only survive but thrive in the world of technology that was surely emerging. Advancements in technology were happening all around. Here are just some of the breakthroughs that happened in 1966. So I picked two of their technology that invented in the year of 1966. Number one, Carter phone. This device connected mobile radios to the telephone network. So number two is Hewlett Packard 2116A, HP's first computer. So 1968 was arguably one of the most productive years in the entire decade. The modern era technology which we use currently is no doubt remarkable and advanced, but it is not common knowledge that their initial conception and modern system design ideas were rooted in the history of technical development, which was developed back in 1968. During this period, the world was in pretty unstable state. So, that's all. Thank you.
The Unix system. What is Unix? Unix is an operating system which was first developed in 1960s and has been under constant development ever since. By operating system, we mean the suite of programs which make the computer work. It is a stable, multi-user, multitasking system for servers, desktops, and laptops. It is also have a graphical user interface or GUI similar to Microsoft Windows, which provides an easy to use environment. However, knowledge of Unix is required for operations which aren't covered by a graphical program or for when there is no Windows interface available, for example, an internet session. So the Unix operating system has three parts: the kernel, the shell, and the programs.
Hi guys, my name is Ox, and I'll be talking about the years 1971 and 1972. So during 1971, the Intel 404 was produced. It was the first microprocessor chip, so it is a 4-bit central processing unit, and it was released by Intel in 1971. It was sold for $60 US, and it was the first commercially produced microprocessor. Now, moving on to 1972. This was the time of optical laserdisc. So in December 1972, a joint public demonstration of a Philips video long play laser player with disc produced by MCA or Music Corporation of America was invented. So this is great for technology, and this is what happened throughout these years.